So first we have to let this is the list. Okay, so let first element is 5. We are implementing the queue operations using a linked list. So first element let 5, we are using the single linked list. So first 5, let the second element is 10 and the third element is 15. Okay, so there are three elements. Now we know that the last part of the last node in SLL is made null. So that's why we cross the next part of 10 to null. Now 5 to 10 and 10 to 15, these are interconnected. So this is the single linked list, and this is your front F, and this is your rear part. Okay, front part and rear part. So this entire will contain your queue. So this is the array implementation of the given queue. So 5, first one is 5, second one is your 10, and third one is your 15. Okay. Now first of all we have to create the node structure. So this is your queue. Your queue has two pointers, so front pointer and the rear pointer. So every pointer, these two pointer, it looks like a node. It has two parts. First part is the data part and second part is the pointer part. Okay, so first we have to create the node structure. So this 5, this 10, this 15, these are the nodes of the linked list. So first we are creating the node structure. So how to create the node? Using a structure. So let the node name is, structure name is node, and we know that it has two parts, the data part, and for self referencing type it has the next pointer, and it's for self referencing the return type is struct node. Okay, and the data part is int data. So this is the node creation. Node creation. So this is the node creation. Okay, now you have to create, you have to uh, declare your queue. Queue has two parts. So here your queue has two parts. First part is the front part and second part is your rear part. So we are using the structure again, and let the name is queue. Okay, now first one is the front pointer. It has two parts, so it is the front pointer, and next one is your, what will be the return type of this front and rear? Any idea? This is the
Struct
front.
node.
Why struct node? Because your, if you break the front and rear, you can get the data and next pointer. Okay, so front and rear are nothing but your elements, your node elements. Okay, so its return type is not struct queue, it is rather struct node. So struct node, and here it is also struct node. Now we just create a pointer variable struct q and q. We are accessing the front and rear using this Q pointer. Okay. Now we have to create and initialize our queue. We have to create and initialize our queue. So create, so let create, so create function. So inside this create function, we are passing your queue as a argument, just like in single linked list or double linked list or circular linked list. We are passing the start, we are passing the start pointer. So start and its return type is was struct node. So here also we are passing the queue and its return type, is your struct queue. Okay. Now what is the initialization condition? Your front and rear must be null. So front is equal to null, front is equal to null, and we are accessing the front using the Q pointer. Okay, so the front element, is accessing here by Q arrow front. Similarly, Q arrow rear. If this is the node number 2, then we can access this by Q arrow new node or node number 2. So Q arrow front. So Q arrow front is null. Similarly, Q arrow rear is equal to null. Okay. So this is the declaration and initialization and the creation of your queue. Now insert function, insertion. So insertion function, let the return type struct queue. At the insert we are writing the insert function, and let there are two arguments. First argument is your Q pointer and second argument is your value, inserted value. So the return type is your value is int and the return type of your queue is, we know that struct queue, not the struct node. Okay, because your queue will contain the entire queue. First of all, suppose this is the 5, 10 and 15 are given. Okay, now let 20 is the element you are asked to enter. So how to enter this 20? So first of all, you have to create this node dynamically. Okay, so first of all, let the new node is your 20. Actually data part is kept in the 20 is kept in the data part of the new node. So what is the return type? Because of it is a node type, so struct node new node. Next you have to dynamically create this. How to dynamically create? We know that using the malloc function. Okay, so using the malloc function, first one is your cast type. So what is the cast? Here struct node star, and next portion is your byte size. So using size of operator we can easily find out the byte size. So struct node. So this is the new node is dynamically created. Now 20 is inserted at the data part of the new node. So 20 is inserted. What is 20? 20 is the inserted value. So 20 is inserted at the, what is happening? 20 is inserted at the data part. 20 is inserted at the data part of the new node. Okay. Now, what is the condition for empty queue? We know that. What is the condition for empty queue? Anyone?
Front equals
Front
equals to minus
front is equal to, we know that front is equal to 0. Front, if the list starts from 0 to n, then front is equal to 0. Or you can use front and rear is equal to 0. Or you can use, if the list starts from if the list starts from if the array starts from 0, then you can find front is equal to -1 and rear is equal to -1, and or operation are there. And if the list starts from 1, then front is equal to 1 and rear is equal to 1. So here, if if your front if your front is equal to null, here we initialize the front is equal to null, so we are accessing the front. That's why arrow q q arrow front. If q arrow front is null, that is your empty queue. So your new, so your so your list is totally empty. So your inserted value, that is your 20, is the only one node. Okay. So this 20 is your only, so this 20 is your front, as well as this 20 is your rear. Okay. So you have to declare so you have to declare this 20 this 20 as the, that is the new node as the front, and new node as the rear. Okay, you have to declare this because this is the only one node. Your list is totally empty. Now q arrow q arrow front is equal to new node, and second line q arrow rear is equal to new node. Okay, and as new node is now becoming your rear and front at the same time, so the, as we are using the linked list, so the next part of the new node is made null, right? So the next part of the new node is made null. So new node, that is your rear and front. So front, front, its next part. So its next part. So its next part. You can modify your program in several thousand ways. Okay. So its next part is made null. You can declare this line number 35. You can declare this line number 35 here also, outside the if block. You can also declare this. And q arrow rear, q arrow rear, and its next part is also made null. Okay, so this is the if condition, line number 32 to 37. So this is for empty queue, full empty queue, and your new node is the only one node. Otherwise, that is your else, that is your list is not empty. That is this current scenario. 5, 10, and 15 are there. Then what are the required operations? First of all, you have to make a connection from the last previous rear to the new node. So this is your first operation. Okay. So for this first operation, you have to delete this cross. Okay. Next one, what is the next one? Next one is that cross this rear, and this will be your next rear. So this is your second operation. So new node will now become the new rear. And the third operation is that new node's next part. That is your rear is new node. So rear's next part or new node's next part is made null. So this is the third operation. So there will be three operations inside the else part. Else part means your list is not completely empty. So how to write else part? So first operation, what is the first operation? First operation is that rear's rear's next part is pointing to the new node. So rear's next part. So rear its next part is now pointing to the new node. We are accessing the rear using the We are accessing the rear using the Q rear, its next part. So Q rear, its next part is now pointing to the new node. So this is the first operation. What is the second operation? Your second operation is that your new node now become the rear. So copy the new node in the rear. So new node will be at right side and rear will be at left side. So Q arrow rear, Q arrow rear is equal to new node. Okay, and and your rear's next part, that is new rear's next part. So what is the new rear? Its next part. Are you getting this? The steps?
Yes, sir.
Okay. So this is the else part complete. And finally, return your Q. Return your Q. So this is the insertion function. This is the insertion function. Okay. Now you have to delete. Deletion function. Deletion function. Please ask me if you have any doubts. So deletion function, first of all, let the delete function struct Q and delete. Let delete element and delete element, that is the just uh, Q is passing. So the return type is struct Q. And how to delete? First of all, deletion can be done from the front end. Okay. So deletion can be done from the front end. So you have to copy this front in a temporary variable. You have to copy this in a temporary variable temp. You have to copy this temporary variable, and then you have to shift the front to the next node, and finally free this temp. So this is the deletion. Very simple. So first of all, your temp, you have to declare your temp. So your temp is nothing but a pointer. So temp, its return type, because of your temp will contain two parts, data and next. That's why its type is node. So struct node temp. Okay, we are not assigning any value. We are now not assigning any variable to the data part. We are just copying the value from front to the temp. That's why you don't use the malloc function here. So temp is equal to copy. So temp is equal to q arrow front. Front part is copied in the temp portion. Okay. Now, what is the condition for empty? We know that its front is if null. If its front is null, we know that. Then just write down underflow. You can't delete anything. Okay. Underflow. You can't delete anything. Otherwise, what should we do? Otherwise, what should we do? Any idea? We have to, the copy is complete, copy part is complete. Then we have to, any idea?
Shift the first part.
Shift the first,
Front.
that is
Shift the
front part.
front to
Front.
next.
So the left, so we are, so what will be the left portion? As in the assignment operator, what will be the left part? The left part will be the new Q, new front. The left part will be the new front, and right portion will be the old front's next portion. So that if basically this is f plus plus, increment the value of f plus plus. Okay, so else part, front, front. So we are accessing the front using the q. So q front. So q front is equal to, we know that its next portion. So old old q's old front's next portion. Okay. So old front. So old front is your, its next portion is copied. Okay, and what we are just showing the deleted value. So the the deleted value the deleted value is, the deleted value is, what is the deleted value? Your temporaries data part. Okay, and finally delete the temporary pointer. So your temporary pointer, and then return q. So this is the delete function. Okay, so this is your for creation, this is for insertion, and this is for deletion. Now you have to display the queue. So let the display function is very easy. Okay, so display. So what is the display? Return type, we know that struct, because we are dealing with queue, struct queue, and we are passing the pointer queue. So struct, so struct queue. Okay, now how to print the linked list? Just we have to use a temporary pointer. The temporary pointer should be scanned from front to last. Okay, so this is your temporary pointer t. Okay, so this t should be scanned from first to last. Okay, so temp struct node, struct node temp, struct node temp. Okay, so first of all, the temp is initialized with, we know that it is initialized with front, so that it can start scanning from left to right. Okay, so the very basic question, if front is null, then print underflow. Just copy and paste. If your front is null, then you show the message underflow. Okay, otherwise otherwise part otherwise part what should be the otherwise part? Else, any idea? You should run up to the last node. So what should I write?
Temp equals to q front.
while while your while your temporary pointer not is equal to rear. So rear is accessing by q arrow rear. So this is the line number 68. Line number 68 can be modified in this way: temporaries next part is not null, both are same. Temporary not is equal to q rear. This is same as temporaries next part is not null. Okay, so you can also do that way. So print f, you have to show the values. So the values are shown in this form. So temporaries data part is shown every time, and you have to advance. So how to advance? We know that temporary is equal to temporaries next part. Okay, and for final printing, final element printing after the loop, where again we have to use the %d and its data part, temps data part. Okay. And finally, return the queue. So this is the display function for display, starting from front to the rear. Okay. Now we have to write the main function. So inside the main function, we are using the do while loop. Okay. So how to write the do while loop? So do while your condition is true or false. So now expanding the do while loop, line number 79. So do while loop, just it should be menu driven. So we are using the switch case. So uh, first one is your let first one is your insert. Okay. And let the second one is your deletion. Delete. Second one is your delete. And the third one, let the third one is your display function. Okay. So the third one is your display function. Number 3, this is your display function. You have to display the list. So first, here I NTF, printf. So first you have to enter your choice. Okay. So enter your choice. Enter your choice. So enter the value. Let this is stored in your variable ch. Okay, so %d, and let this is stored in a value ch. So you have to first declare the int ch. So enter your value. Okay. Now we have to use is WITCH switch. So we have to use the switch case. So switch case, we are passing the ch our option. So first option is your case 1. Okay, case 1. What is the case 1? Insertion. Insertion is your case 1. So we have to insert a value. That's why we are taking the value. So enter your data. Enter your data. So enter your data, and the data is stored in let variable in. Data is stored in your variable let in. So you have to initialize, you have to declare this in here. Next, for insertion, insert, and first argument is the q and second argument is the in, right? And then break. Now case 2, this is for deletion. Okay, so q is equal to call the delete le. Know that delete le is just a q, then break. Case 3. So case 3. So case 3 is the display. So how to display? Just call display function and break. Break. So what is the condition? While loop. While there are 3 conditions. Okay. So while your choice less than 4. While your choice less than 4. Now first of all you have to call the create function, create queue. Now create queue is there, and queue should be dynamically allocated. Queue is a node here. Queue is the node here. Okay. So node structure here, struct node struct node and malloc size of struct node. Okay, so this is the main function, and queue display function. This is the delete LE, and insert. This is your queue create function and queue. Okay, so build and done. So first option is insert. So enter your data 5. Next again enter your choice, enter your data 10. Again insert, enter your data 15. Okay. So now display. So 3. So 5, 10, 15. Is it visible? 5, 10, 15 to
Yes, sir.
you? Now this is the first in, first out data structure. So what is the first entered element? 5 was the first entered element. Now call the delete function, dequeue function, okay, rather dequeue. So call the dequeue function. So 5 is the deleted value. Okay, so display. Now display 10 and 15. Okay, so the deleted value is, just one second, insert. Okay, so the deleted value is, you should inform me. The deleted value is, so 1, enter your data 5. 1, enter your data 10. 1, 15. So display 5, 10, 15. Delete. Deleted value is 5. Okay. Then display 10 and 15. So first entered element was 5, then 10, then 15. But as this is the first in first out data structure, so 10 is 5 is deleted first from the front end. The remaining elements are 10 and 15. Okay. Is it correct?
Yes, sir.
So this is the simple program, very simple program for linked list representation of the queue. So your assignments. So what are the assignments? Just one second. Your okay. Your assignments are, you have to. There are two assignments. Submit by tomorrow. Submit by tomorrow. First one is the array implementation of the queue, and second one is the linked list implementation of the queue. Okay. Submit by 7th November. So I'm stop the recording.